assistance for personalized rTMS treatment for major depressive disorder. Okay, so exploring the use of AI-powered tools to enhance personalized repetitive TMS for patients with MDD. So AI-powered rTMS, transforming patient data interactions. AI is set to revolutionize the way healthcare practitioners interact with their patient data. By leveraging advanced algorithms and machine learning techniques, AI-powered systems can automate data processing, enhancing patient monitoring, and provide real-time insights to support your more informed decision-making. This will empower practitioners in rTMS to deliver more personalized and efficient treatments, leading to improved patient outcomes. No, we aren't going to, make your TMS machine come to life and start walking around the office. Not yet, as you can see in the video of a future TMS device walking around a healthcare setting. But we will give you access to a large language model that will allow you to prompt and question your TMS data in the same way you could ask a person, a TMS assistant, who has doctorate level knowledge of rTMS in research and a clinical setting and can guide you in your TMS practice. So first we talk about a little fine tuning, what we had to do with AI to make it available to you and for it to make sense in a clinical practice or in a research setting even. So what we did was we did a bit of fine tuning. Fine tuning allows a model like ChatGPT, let's say, you take the model and you improve upon the model's behavior, not only by fine-tuning it with data that you have in a data set like the global TMS data set, but also by uploading data to the assistant. So the assistant sort of has this workbench of data that it can look at. For example, the global TMS data set, a local TMS data set. So you're looking at, my clinic's data versus the global TMS data, so I can see what my response rates are like versus the response rates of everyone else, which is nice to have. So these are some of the domains, knowledge domains our assistant will be capable of. Also, another nice thing with assistants is that you can throw a bunch of research at them and they just, they eat research for breakfast. So our TMS AI assistant has access to thousands of the latest research, TMS research. So you can query and ask it questions to your heart's content about anything and all things TMS, about the latest research, popular trending TMS research, and then once you find research you're interested in, diving down into that research to find out more about it, to get more detail on it. So we basically are unlocking invaluable insights to improve patient outcomes. We analyze our TMS treatment data that we have from the PHQ-9s. We identify response patterns and predictors. We optimize treatment protocols for improved results. Again, early detection with an AI assistant can find out who's not doing well. We can change the protocol, can make suggestions on alternative protocols based on patient history and patient demographic. So really, really cool to have that. So you'll have enhanced clinical decision making. So when you do make these decisions on how to treat the patient, you'll be more informed, you'll be more confident because you'll have all of this data behind you. So here again are the different parameters of TMS protocols which we can study with AI, right? Frequency of the rTMS. How often are they getting it? Sorry, not how often. That would be the frequency of the sessions. the frequency literally of the protocol. 10 hertz more effective than 1 hertz. What about 5 hertz? What about theta burst? Then we can also target brain areas that seem to be more effective. For example, maybe we find that right DLPFC isn't quite as effective as dorsal medial PLFC when PFLC when doing. I think there's a lot of acronyms here. When doing treatment for anxiety or 1 hertz. So we can look at brain areas, the duration of the TMS, how long is the session lasting, how many sessions per day, and then we can use these algorithms to come out with individualized approaches. So we get an AI-driven protocol suggestion. We can dynamically adjust the protocol based on what's going on. Of course, there's going to be human input here, just to make sure the AI is suggesting a good protocol and everything looks good. And then we optimize the machine parameters. How intense? Do we want to treat at motor threshold? Do we want to treat 120% motor threshold? Is there some sort of a correlation between treating this patient at 60% versus 100% motor threshold? That sort of thing we can look at with AI. Here we examine session frequency. Again, how often are the sessions happening? How many sessions per day? There's been several papers showing that multiple sessions per day improve patient outcomes. So that's interesting to note. Also, again, as I said before, our AI assistants are trained on thousands upon thousands of TMS research data. Not only does it contain the DOI links and authors for each paper and the abstracts for each paper, it also contains the number of citations, so it can find you the most popular research, the most trending research in TMS right now by year. So this is sort of like having a PhD level doctorate right next to you doing their doctorate, their focus on TMS, and they're up to date on all of the latest TMS research, of course, because that's all they do for breakfast, lunch, and dinner is look at TMS research. Now that is like having a doctorate next to you while you're doing your TMS workup for a patient, which is just wonderful. I mean, the power in that, instead of having to go to PubMed or Google Scholar and then comb through all of the different search results, try to find out what the citation count is. Some places don't include citation count, like you can't get a citation count on PubMed, for example. So you don't know if you're looking at TMS research that was cited maybe 3 times versus something that was cited 2,000 times, like the O'Riordan study done in 2007. Again, as we talk about this, we always bring up suicidal ideation and early detection, which we believe is very important. As you're monitoring your patients, we can use the assistant to detect non-response in ideation, suicidal ideation, so that we can monitor and change up their TMS protocol and add other modalities to their treatment, sort of an intervention, so that we can stabilize the situation, stabilize the patient. So here, some great things about improved patient outcomes. You're reducing the depressive symptoms as shown in your surveys by the AI assistant, which brings confidence into the practice that what you're doing is working. This increases treatment adherence by the patient, increases confidence overall, because the AI assistant can also generate nice, beautiful reports for the patient to look at, which covers the history of their treatment and their outcome. So you would have faster symptom improvement, again, because you would be monitoring these response times for patients, and overall patient satisfaction will increase. So again, some of the benefits that we've gone over. early detection, as we talk about a lot now, clinical insights across global and local TMS data sets, right? So now you have access to a global TMS data set with over 200,000 sessions, over what was it, 30, 40,000 surveys. I mean, that's a lot of data and corresponding TMS protocol data. So now you know what are the most effective protocols out there that physicians are using. And of course, staying up to date with the latest TMS research. And that is it. And so now I'm going to give you guys a demo of our latest TMS assistant, of course, aptly named ChatTMS.ai. This assistant has come together over the course of the last year as we've been working closely with OpenAI and some of the other technologies out there to develop a full-fledged TMS assistant that can be integrated into your practice. We like to make it transparent, so it helps you, but doesn't interrupt you. Doesn't sort of get in the way. It just sort of gets you the right information and then gets out of your way, so you can focus on the patient. And so, without further ado, I will go ahead and just launch that now and share my screen with you to show you our TMS assistant that we've been working on. As far as I know, I think it's the first TMS assistant or the first dedicated TMS assistant in this field, in this available commercially. Okay, are you guys able to see this now? Yes, I think you can see it now. Okay. Introducing ChatTMS one more time, just for completeness. Okay, so this is your AI-powered TMS assistant for your practice. You can sign up for this right now. It's $99 a month for customers who don't have our devices or our Cloud TMS Plus already, and $49 a month for those of you who already have our Cloud TMS Plus package with our devices. This is, again, TMS device agnostic. You can use this with any device. Just 1 second here. Getting a phone call. Want to check, make sure everything's okay. Okay, I'm back. All right, so just getting some live feedback here, making sure everything's going okay. All right, so I understand now you had a blank screen there for a moment. Sorry about that, everyone. We should now be able to see the screen. So this is our addition to AI in the field of TMS. It is called ChatTMS, and it is an AI-powered TMS assistant for your practice. And you can sort of see here on the website, it's very easy and simple to see what it does. You can see you have an assistant, you have a feature for the patients in your practice, and then you have surveys, okay? So this sort of gives you an easy way to monitor and track your patient progress and integrate AI into your clinic. So without further ado, let me go ahead and go to the dashboard here. All right, now you should be able to see this okay. Let me see if I can. Okay, so I made this a bit bigger. So you can see the assistant here. And it auto-generates questions for you. So based on its data set. So let's go ahead and say, before I start talking with the assistant, let's make sure he's there. There we go. Okay, assistant's there and happy to assist us today. Great. These live demos can always be a little risky, but it looks like we're going to be okay today. Hopefully I'm not speaking too soon. So let's go ahead and go to patients, just to give you a basic overview. Here's me, entered yesterday. Okay, and then you can enter a new patient pretty easily. We're going to make it easy for you to import data from your TMS machines, regardless of what kind of TMS machine you have. And then here's a survey. So here's the survey section. So if you want to do a new survey, you select a patient. We only have me in the system right now. And then we, just for simplicity, we just have the PHQ-9. So we will generate a link. And this is the link for that survey. Or if you want, go ahead and send a survey to the phone number. My phone number, this is me, 617-275-3886. So maybe I'll edit this out of the final video. But that will text a link, a magic link, this link, to the patient so they can fill the survey out. So let's go ahead and go to that link so you can see how that looks, okay? And there's a slight delay from when I'm actually talking and when you're actually hearing me. So if you do see a black screen, it's just that I'm switching between different screens. And hopefully didn't forget to share my screen again. But hopefully this is the final time I'll be sharing the screen anyway, so it should go pretty straight. It should be pretty straightforward from here. Okay, so here having people ask me to repeat some of these things. So let me go ahead and show you what we did. So now you can see the screen. So we asked the assistant, what is the most effective TMS protocol based on remission and response rates? This is from the global TMS dataset that our assistant has access to. So it goes and inspects the file. It finds the data that it needs. Kind of, don't really have to pay too much attention to, the thoughts that it's having as it's doing the analysis. This is sort of just the AI assistant thinking through the problem and trying to answer your question the best it can based on the data that it has. Okay, so here it finds that the most effective protocol we have in our data set, based on over tens of thousands of sessions, tens of thousands of surveys, is a theta burst, ITBS, intermittent theta burst combined with 1 hertz. And we see a remission rate of 56.9, so about 57%, which is incredible, and a response rate of approximately 77%. So that's an incredible response rate for a protocol. Can you tell me how many patient cases were involved with that protocol? All right, well, we might be interested to know how many cases does that data actually represent? Because, of course, we have a lot more data on depression 10 hertz than we do theta burst with 1 hertz. So you want to make sure we have a good amount of data. And so you're not looking at some data that's just, derived from 5 patients or something like that, which is the case with some of the research we do see in PubMed. 153 patient cases, okay? So let's say, what is the, can you give me a table of protocols based on how, can you give me a table of response rate percentages by TMS protocol type? You have to be, as clear as you can be. Usually the language model, the AI assistant can understand you, but it's nice to be a little extra clear when you're asking it questions. Let's see if it does this correctly as it should. Oh, isn't that beautiful? So now we have a table of all of the different response rates. You can see coming down at the bottom of this is depression 1 hertz by itself. So we can see we're probably getting our best responses with higher frequencies. And interestingly enough, when you combine uh, 1 hertz with ITBS, it ends up being a very powerful combination. You can see depression 10 hertz by itself, also very powerful. 75% response rate's incredible. And you can see that doing more sessions in this case worked out. But we want to make sure there's not as much data for people who got 50 plus sessions of 10 hertz, because a lot of people don't get that many sessions. How many cases were involved with the depression 10 hertz 50 plus sessions? See, just 32 patient cases. How many patients involved with depression 10 hertz by itself? Let's see. So this is patients who simply just received depression 10 hertz by itself. We have a total of 523 patient cases here, which is incredible. That's 523 people that received just depression 10 hertz, and you can see their response rate is incredible, right? For depression 10 hertz, 63%. Okay, so it's much better than the research, but still not as good as your ITBS 1 hertz combo. ITBS by itself is more effective. So again, isn't this incredible? You get this fast, intelligent overview of your patient TMS data, and this is going off PHQ-9. So let's go ahead, based on GAD-7s. And what are the top 3 protocols for anxiety? Probably going to be similar to the ones for depression. That's it, they're so interconnected. But just to show you, we can answer questions like this. So ITBS again, depression 10 hertz, 1 hertz combo was the most effective protocol for anxiety for GAD-7 improvement. So you can see we have the ability to monitor across several survey types. And let's see, how about how did patient females age 20 to 40 respond to depression 1 hertz? Let's see, 20 to 40, we have the age ranges from 20 to 40, 40 to 60, 60 to 80, and then we have the 0 to 20, 80 to 100, just to keep things standardized. Okay, so we'd add a response females, if you're between the age of 20 and 40, if you're just doing 1 hertz, and this is 1 hertz, which is standard protocol for 1 hertz is on the right side. So this is for depression 1 hertz on the right side. Again, we can find these details. Either you can ask us for clarification, or the assistant will have a clarification for you as well. So females have an approximately 58%. So let's ask, what patient demographic responded the best in your surveys data? Just to make sure before you publish the research paper that you dot all your I's and cross all your T's. There are people who use this for, like a paralegal, for example. There have been occasions where it simply references a case study that doesn't even exist. So again, 80 to 95% of the time, you're getting an accurate answer, but occasionally you do get they call them hallucinations, and they should be mitigated in following releases. Okay, so let's go ahead and ask it about some research. Okay, so can you tell me about the latest TMS research for OCD? Please include DOI links and citation counts. All right. It's much less likely to hallucinate with research data or anything like that, because These questions are simply factual, don't require any or much analysis. So the AI doesn't have to really think too hard about questions like this. So here we go. Here's, can you give me studies, TMS studies done for ADHD, popular studies. For ADHD, and some of the results seen with treatment. Okay, here we have treatment of ADHD. We have the authors, year 2021, 778 citations. This review highlights improvements in ADHD treatment outcomes in adolescent patients who participated in. So you can take the, apparently the DOI wasn't available for this one. Let's see. You can take the DOI link, which in most cases it should have, and go ahead and go to PubMed or Google Scholar, and you can further dive into this research. And in a lot of cases, the assistant will have access to this research too. In many cases, it will have the full paper, so you'll be able to analyze it with the assistant here. Okay. Can you tell me how many females versus males we have in the global data set? Can you make a pie chart out of it? All right, let's see what it does. Okay, so we just want to see how many males versus females we have in our data set. Just might like to know, just some interesting information. Okay, so, sometimes it has to work with the files, so it will talk about what it's doing. So it's trying to load the JSON file which contains the data. Oh, here we go. Okay, as you can see in our data set, we have quite a lot of females as compared to males. And that's sort of consistent across a lot of different data sets. That could be females are more open to treatment, alternative treatments, or they just happen to be a lot more depressed females in the United States at the moment than males. Or they're more likely to seek treatment for mental health than males. So there's many different reasons this could be the case, but this is representative of the global data set. Okay. And so that's basically it. That's just sort of a high-level overview. Again, now if we want to get into a new conversation, we just click this. It will generate some questions. We can ask it whatever we want. This assistant will also automatically email the practitioner if there's suicidal ideation in the surveys. You'll also have a little warning system come up here when you have the assistant. It will sort of like some like Bank of America on their app has an assistant which shows you different trends that are happening in your data. So again, this is a feature we're working on now that will show you, any alerts that you have coming up. Just by clicking on the assistant, it's going to do a diagnostic check on the current patients you have, and just to make sure that none of them are having suicidal ideation, and they aren't, and that they're getting better. And if they're not getting better, we want you to know about it. Also, we'll highlight successes so you can see what's working with your patients. Let's see, how effective is TMS combined with neuroimaging schizophrenia? So it generates these questions dynamically. So we'll have different questions every time. What are the implications of TMS on treatment? Okay, let's see what this says. So it must have some access to an interesting study with neuroimaging and schizophrenia. Okay, so anyways, you can see how fast it is and how fast it responds. And that's basically it. So I'm going to go ahead and stop sharing now. Okay. So we've just gone over research literature that the assistant has access to. Again, thousands of research capabilities that you wouldn't just get by firing up PubMed or by using Google Scholar. This is a TMS research assistant used and trained specifically on TMS research data, kind of like a search TMS feature that the assistant has. And the assistant can search through thousands of these research articles, so you can chat with these research articles on TMS in a natural language format. The TMS assistant has access to a global TMS data set, as we've covered, that goes over thousands of patient studies and surveys to show you the most effective protocols. And finally, the assistant will be able to do an early detection / warning system for our practitioners to warn them about patients that are not responding and warn them about suicidal ideation, amongst other things. So, other parameters, treating them at 120% motor threshold versus 20%, treating them 3 times a day versus 10 times a day or once a day, treating them for 6 weeks versus 3 weeks, or treating them for maintenance sessions. These are all things an AI assistant can come in very handy. So this assistant will have access to all the latest TMS data, the global TMS data set, which is connected to all of our cloud TMS devices in the United States, right? We have hundreds of them available, which have collected hundreds of thousands of sessions. And finally, a local representation of your data. So this assistant can help you with your local data. Why isn't John Smith getting better? Why isn't Maggie May improving her depression? And maybe we can change up the protocol or switch the frequency of the sessions for these patients. Once we have the ability to really tightly monitor these things in our own clinic, and then we can see how our own clinic is performing versus other clinics and the global clinical data set. Like I said, I'm pretty sure this is the first intelligent chat interface for a global TMS data set, unless one of the other major TMS companies has released one. But as far as I can tell, and some of the preliminary research I've done, this is the only commercially available TMS chatbot or specialized chatbot that is out there. And that concludes the presentation. And I'm going to open up the floor for questions. And we'll just give it about, since we've, an hour and a half. I thought this was going to go for 30 minutes. I probably did a little too much on the AI in the beginning and maybe some of the PHQ-9 tracking, but I just sort of wanted to build up to a solid understanding. So go ahead and ask questions at your convenience. Keep in mind there's a little bit of a delay between when I'm talking and when you're asking questions, so it might not seem super straightforward when I'm answering them before we conclude. So I'm going to go ahead and ask anybody with any questions on the chat. Okay, so just waiting on some questions. We'll give it a few minutes here. If we don't get any questions, we'll just close it down. And if we get some questions, I'll do my best to answer them here. And then if you're seeing or watching this at a later date, maybe email us contact@cloudneuro.com or fred@cloudneuro.com. If you have any questions, you can also leave them in the comments on the video. And for more information about us, cloudneuro.com. That's cloud, Neuro.com. And for the product demonstration we did earlier, that is called ChatTMS. It's our latest innovation for sort of a TMS dashboard, an intelligent TMS dashboard for all TMS practitioners, anybody interested in TMS research or learning about their TMS clinical data, and enhancing their patient outcomes using AI, this is for you.